What I have set up here is a gas collection setup. I've got the graduated cylinder inverted. It's full of water and it's in a tub of water. And the way this works basically is you have the gas go into the graduated cylinder, and of course it's less dense, so it's going to rise to the top, which is going to push out some water. That way you can measure the volume of the gas. And the way this kind of works is basically it's going to equalize the pressure. In other words, the pressure inside, the pressure of the gas inside the graduated cylinder is going to be equal to the atmospheric pressure that's pressing down on the water, that's pushing the water up inside the tube. That's why the water stays in the tube. It doesn't flow out. As long as this end of the graduated cylinder is underneath the water, air pressure pushing on the pool of water here will keep it pushed up inside there. But as I start bubbling gas inside there, it will push out some water, and the pressure of the gas inside will be equal to the pressure of the gas outside, the atmospheric pressure. Now I'm going to measure the atmospheric pressure using a little gas pressure sensor. There it is on the camera. I measured that and it came out to 98.8 kilopascals, I believe. I have a screenshot of that I'll attach as well. And you can also do this before the days of, or if you didn't have one of these, pressure sensors, you could look it up on, weather.com or something like that, and they always give the atmospheric pressure, but that's for your local area. So hopefully our reading that we're getting with our sensor here is for this room under these conditions right now. All right, let's look at the rest of the setup here. What we're going to do. What I have done is I have taken apart, and here's the rest of it, a little aim flame, a lighter, like a camp lighter or whatever you might call it. Aim flame is what I call it. So here's the rest of the pieces, but basically all I really wanted is what's on the balance over here. I've got the tank of fuel, which is butane, and I've got the trigger here that releases fuel out the little tube right here. And the reason I have it on the balance is I want to get a reading of the mass before we get started, and it looks like it is 44.64 grams. Now what I'm going to do is I'm going to release some of the gas by pushing on the trigger here, and I'm going to release some of the gas through the tube, and that tube will be up inside the bottom of the graduated cylinder. I'm going to collect the volume of gas, and then we're going to do some calculations here and try to figure out, ultimately what we're trying to figure out is what is the molar mass of butane. And of course we can get molar mass. Molar mass means grams per mole. So that means we need to know grams, which is why I put it on the balance. And we need to know moles. And we're going to calculate the moles using ideal gas law. You guessed it. And partial pressure as well, right? Because we're collecting the gas over water, right? The water inside the graduated cylinder. Some of that pressure, remember I said earlier that the pressure inside the graduated cylinder is going to be equal to the pressure outside the graduated cylinder, the air pressure outside. Some of that pressure inside the tube, however, inside the graduated cylinder comes from vapor pressure from water, as we have discussed before. All right, so let me go ahead and see if I can do this without making too much of a mess. Take my watch off here. And I want to try to not get this wet as much as possible. Just get the hose wet here. All right, let's stick that underneath. And you can see as I release the gas, it goes straight up in there. I'm going to try to collect right at 100 milliliters. Hopefully I'm not the other way. Whoa. I'm getting close. Very close. Okay, that looks to me to be 100 milliliters. Okay. Now I am going to dry this off. The hose got a little bit wet, so I don't want to weigh the water if I can avoid it. And now I'm going to weigh this guy again. And now it is 44.10 grams. Okay, now we should be able to do our calculations here based on pressure, right? We've got the pressure, the atmospheric pressure should be equal to the pressure inside the graduated cylinder. We've got the volume is 100 milliliters. And the temperature, well, I'll have to give you the temperature. Forgot to measure the temperature in the room, but I'll get that to you in just a bit. And we have the ideal gas constant, of course. We have to use the right one that matches our units here. And we can use all of that and the ideal gas law to find the moles. And if we have the moles and the mass of the butane, then we can calculate the molar mass of butane. Looks like it's dropped, oh, no, 44.10 is our final mass there.